Hello and welcome back to the Pelvic Empowerment IBS series. My name is Tori and I am a doctor of physical therapy who specializes in pelvic dysfunction, which means that I treat things that can go wrong around the pelvis, and that includes bowel dysfunction. Last year, I decided to try my best to unpack what I have learned about IBS in a video series. And today I wanted to add a 7th installment to that series that really focuses on a low FODMAPs diet. What is a low FODMAPs diet and how could it potentially help someone with IBS? If you've watched the previous 6 videos in this series, you know that my last video, Dietary Considerations for IBS Symptom Management, didn't focus on diet as a cure for IBS, but instead focused on how you could use one diet to potentially manage symptoms of IBS. More specifically, that diet looked at how can you manage the gastrocolic reflex and the intestinal muscles in order to decrease symptoms associated with irritable bowel syndrome. The low FODMAPs diet also isn't aiming to cure IBS through diet, but is aiming to manage IBS symptoms just through a slightly different lens. Instead of really zooming in and focusing on the gastrocolic reflex, a low FODMAPs diet really zooms in and focuses on how the bacteria in our gut break down certain foods and how that breakdown affects the intestinal muscles. In order to understand fully the theory behind a low FODMAPs diet and how a low FODMAPs diet could potentially aid in soothing IBS symptoms, you have to have a good basic understanding of the GI system and a good basic understanding of the bacteria that live in our GI systems. So that is where we will begin today, and then we will unpack the acronym FODMAPs and make sure that every word makes perfect sense before talking about how a low FODMAPs diet could help with IBS symptom management and how that diet would work. What does that diet look like? As always, you can check below for timestamps if you want to jump around. You can also check out any studies or resources mentioned in this video. They'll all be linked below, and you can also find links to all of the previous videos in this series. Let's begin with a quick review of the GI system. The GI system starts with your mouth and ends with your anus. Food goes in and a bowel movement comes out. So food starts to move through your GI system, through your digestive system, when it enters your mouth. You put it in your mouth, you chew it up, and you swallow it. And once you swallow it, the entire process becomes automatic. You don't have to think about what your digestive system is going to do next, nor do you have voluntary control over what your digestive system is going to do next. So you swallow the food and your brain signals your GI system to begin something called peristalsis. Peristalsis is the rhythmic contraction of the muscles that make up your GI system. These rhythmic contractions propel food and eventually waste all the way through the GI system until they end up in your rectum and eventually in the toilet as a bowel movement. These rhythmic contractions, peristalsis, it looks a lot like it does when a snake eats a mouse. You can kind of use that visualization to see in your mind what those muscles are up to. So when you swallow food and it goes down your esophagus, it is esophageal peristalsis. It is these rhythmic contractions of the esophagus that are propelling the food down your esophagus and eventually into your stomach. Once that food enters your stomach, it is churned and broken down, and eventually it exits your stomach and it goes into your small intestine. The majority of digestion takes place in your small intestine. Recall that digestion is the breakdown of foodstuff into substances that can be used and absorbed by the rest of your body. So as that foodstuff exits the stomach and enters into the small intestine, your small intestine is digesting the food. That substance, whatever can be reabsorbed and used by the body, is making its way through the small intestine, and the body is absorbing what it can use out of that food stuff. And then eventually the waste products of that digestive process and foods that aren't digested well make their way into the large intestine. The waste continues to move through your large intestine via that peristalsis peristalsis via those rhythmic contractions of the intestinal muscles. The large intestine absorbs some water from that waste and helps turn that waste into solid stool so that it can eventually end up in your rectum, and then you can have a bowel movement and it can exit as stool through your anus. Now that we've reviewed the GI system and we've kind of followed food from the mouth to the anus when it exits the world as a bowel movement, I don't think it is quite as difficult to imagine the digestive system simplified as a singular tube. You can appreciate that if we were going to simplify the GI system into that tube, like I was saying, that you have food, and that food would go into your mouth, down your esophagus, it would mix and turn in your stomach, it would go into your small intestine where the majority of digestion takes place, through the large intestine, it would make its way down into the rectum where it's eventually actually stool, waste, poop, and then eventually that stool, that waste would exit your body via your anus when you have a bowel movement. Now, let's zoom into bacteria and how bacteria are kind of dispersed within the GI system in healthy individuals. The stomach and proximal small bowel, the duodenum and jejunum, normally contain few bacteria. In contrast, the terminal ileum has significantly more bacteria, and the colon has even more bacteria. So if we return to that simplified tube that we were using earlier to describe the GI system, the small intestine can actually be broken down into smaller parts, into 3 smaller parts, into the duodenum, jejunum, and the ileum. The duodenum is closer to the stomach. It is the upper third of the small intestines, if you will. It would be kind of in this space where the stomach connects to the small intestine. That's the duodenum. The next section, the jejunum, is in between the duodenum and the ileum. So kind of that in-between middle space, that would be the jejunum in the small intestine. So more in this area. And then the ileum, the terminal small intestine, that just means that's the end of the small intestine. That is the farthest away from the stomach. That is the part of the small intestine that connects with the large intestine. So the ileum would be here. Duodenum, close to the stomach. Jejunum, kind of in the middle, and ileum, farthest away from the stomach, connects with the large intestine. And then colon is just another word used in the scientific community to describe the large intestine. So finally, if we add bacteria to this tube in the way that they present in normal, healthy individual GI systems, you can start to see that you have fewer bacteria the higher up you are, the closer you are to the mouth, and you have more bacteria the farther away you are, the closer you are to your anus. So said another way, the stomach, the duodenum, and the jejunum have very few bacteria, but the ileum, so very few, but the ileum has quite a bit of bacteria, and then the colon, the large intestine, has a ton. If you flip this image on its side and kind of look at it like food starts here in the mouth and ends here in the anus, which means that this would be the beginning of the digestive system and this would be the end, you could kind of picture it in graph form. That means that bacteria are going to start low, less, there's not that much, all of a sudden you have more in the end of the small intestine, then you get to the large intestine and you have a ton. So now that we have reviewed the GI system, we're familiar with how food moves from the mouth to the anus, and we have investigated the gut bacteria and we kind of have a better idea of where they live in the GI system, we can finally start talking about FODMAPs. Let's begin by breaking down the acronym itself and making sure that every word in the acronym makes sense. So we know that the word FODMAP stands for fermentable oligosaccharides, disaccharides, monosaccharides, and polyols. But what do those words really mean and what do they have to do with IBS symptom management? Let's start with the first and, in my opinion, the most important word, fermentable. In its most general sense, fermentation is referring to the process of bigger, more complex organic molecules being broken down into smaller, simpler organic molecules by microorganisms like bacteria and fungi. A really familiar and easy to grasp example of fermentation is alcohol. Think about fermentation as the process of bigger, more complex organic molecules like sugars and starches, like grapes and hops, being broken down into simpler organic molecules like alcohol by yeast, by fungi. But fermentation happens in our guts too. Fermentation happens when certain foods that we eat are delivered to the bacteria that live in our guts. Those bacteria break down that foodstuff into more simpler molecules that they can use as fuel, that they can use to feed other bacteria that live in your gut, that they can use to help your colon cells, and that can sometimes be used as prebiotics. So there's lots of good stuff. Fermentation isn't necessarily a bad thing, but it's something that happens in our guts naturally. But here's the thing about a food being fermentable. In order for any foodstuff to be fermentable, it has to be poorly digested. Recall that digestion is the breakdown of foodstuff into substances that can be used and reabsorbed by the body, and that the majority of digestion happens in the small intestine. Also recall that the majority of these fermenting bacteria live at the very end of our small intestines or in our large intestines. So it starts to make sense that the only way that these bacteria can come into contact with this food is if that foodstuff makes it all the way to them. And the only way to make it that far along in the digestive tract is to be poorly digestible. Otherwise, whatever it is that we're eating would be digested higher up in the small intestine, and it wouldn't make it to the end of the small intestine or to the large intestine where these bacteria live. Poorly digested food isn't a new phenomenon. I think we can all imagine, we can all think of examples of poorly digested foods that we've seen make it all the way through our digestive system. I think a really palpable example is pooping and noticing that there is corn or quinoa in your poop. Okay, so now that we have unpacked the F in FODMAPs, now that we have a better idea of fermentable and what it means, let's unpack the ODM, the oligo, di, and monosaccharides. The word saccharide comes from the Latin word for sugar, and that's exactly what it means in this context. Oligo, di, and monosaccharides are simply different kinds of fermentable sugars or fermentable carbohydrates. A monosaccharide is the simplest form of sugar. It literally translates to one sugar. A monosaccharide is the most basic unit of a carbohydrate, and examples include glucose, fructose, and galactose. A disaccharide, which literally translates to two sugars, is when two monosaccharides are joined or linked together. Examples of disaccharides include sucrose, maltose, and lactose. The word oligo comes from Greek, and it translates to a few. So oligosaccharides literally means a few sugars, and in most of the literature it's agreed upon that an oligosaccharide is somewhere between 3 to 10 monosaccharides joined or linked together. Common examples of oligosaccharides are fructans and galactans. So to recap, oligo, di, and monosaccharides are all sorts of short-chain carbohydrates, and the reason that they are significant in this context is because they are poorly digested short-chain carbohydrates, which means that they will make it to our gut bacteria where they will eventually be fermented. Let's end with the last bit of the acronym, the AGP, which stands for end polyols. Polyols are neither truly sugars or alcohols, but their structures resemble sugars and alcohols, and so they are known in the scientific community as sugar alcohols. They are found in certain fruits and vegetables, and they're also really common in artificial sweeteners because they don't have a large caloric effect. Why? Because they are poorly digested in the small intestine, which means that they make their way to the gut bacteria that live in the end of our small intestine and in our large intestine, which means that they end up being fermentable. But why are FODMAPs important to someone who is trying to manage her IBS symptoms with diet? Why do we need to name these fermentable short-chain carbohydrates and sugar alcohols? The whole hypothesis of FODMAPs being potentially helpful in managing IBS symptoms is built off of what happens in our intestines to our intestinal muscles when these foods are fermented by our gut bacteria. Ingested fermentable oligosaccharides, disaccharides, monosaccharides, and polyols are poorly absorbed in the small intestine. Their small molecular size results in an osmotic effect, drawing water through to the large intestine. FODMAPs are then fermented by colonic microflora, aka gut bacteria, producing hydrogen and or methane gas. The increase in fluid and gas leads to diarrhea, bloating, flatulence, abdominal pain, and distension. So let's break that down and make sure that everything that was said there makes sense. I think that we know now and we understand that FODMAPs are not well digested. They are poorly digested in the small intestine. An osmotic effect simply means that FODMAPs tend to attract water into the intestines. Whether it is the molecular makeup of the FODMAPs themselves or it is the byproducts that end up being excreted by the bacteria once those FODMAPs are fermented, it doesn't really matter. What does matter is understanding that FODMAPs tend to have an osmotic effect. FODMAPs tend to attract water into the intestines. FODMAPs also tend to result in the production of gas. When your gut bacteria ferment FODMAPs, they end up producing hydrogen or methane in most people. Knowing this, you can start to actually visualize, actually imagine what's happening inside of your intestines when you ingest FODMAPs. If you imagine the intestines this time as a really simple tube, just imagine that this is the intestines. And now imagine that you've eaten something that has FODMAPs in it and the bacteria living in this tube are starting to ferment that foodstuff. So the first thing that's going to happen is that osmotic effect. The FODMAPs are going to draw water into your intestines. The next thing that's going to happen is the production of gas. Those gut bacteria are going to ferment that foodstuff and they are going to produce hydrogen and or methane gas in that tube. Both of these processes take up space. Both of these processes fill up the intestine. And it's not that crazy to imagine that intestinal tube filling with water and filling with gas ends up putting pressure on it, ends up creating pressure within the intestinal walls. In a normal, healthy gut, this really isn't a big deal. That osmotic effect, water entering the intestines, can actually end up having a laxative effect for some people. It'll just make stool that was a little hard a little bit softer, and for other people, it will end up being reabsorbed later on as that foodstuff makes its way, as that stool makes its way farther along the large intestine. So again, in a normal healthy gut, this osmotic effect is not really a big deal. The gas also in a normal healthy gut isn't really a big deal. It just ends up being normal, mundane flatulence later. But in people who have IBS, it's agreed upon in the literature that there is some sort of sensitivity going on with the actual intestinal muscles themselves. That extra water and that extra gas taking up space in your intestinal tube is going to put pressure on your intestinal muscles, and that kind of pressure can be a signal to your brain to jumpstart peristalsis. And if you've watched my previous videos, you know that there's kind of a hypothesis that peristalsis might be abnormal in people who have IBS. So if you jumpstart peristalsis with all of this gas and all of this water, you can end up with an overactive response, which would send your stool really quickly through your GI system and give you diarrhea. And you could potentially end up with that underactive response where you get constipation, things move really, really slowly, although the research does support that low FODMAPs diets tend to help people who have more diarrhea dominant IBS symptoms more often than people who have more constipation dominant symptoms. But that doesn't mean that it still couldn't be helpful for both. It just tends to be more helpful for those with the diarrhea dominant symptoms. But that being said, you can imagine that that kind of jump-starting peristalsis behavior could be really aggravating, and you could also imagine that all of that gas, if your intestines are hypersensitive, if they don't react the way that you'd want them to react normally, that could cause bloat, that could cause abdominal pain, that could be really uncomfortable. And that's the whole idea, that's the whole theory behind a low FODMAPs diet. If we can't control and can't change the actual cause of IBS, can we change the way that our gut bacteria are behaving? Can we lessen the irritating osmotic effects and the irritating gas production that could be happening when these bacteria ferment certain foods that we eat? Great, but how do you implement a low FODMAPs diet, and what foods are considered to be high and low in FODMAPs? I think the answer to this question can be really frustrating, but it comes with really good reason. A low FODMAPs diet is trickier than other lifestyle diets because in no way is it meant to be a no FODMAPs diet, nor is it meant to be a forever diet. It is truly an elimination diet that is used to figure out what specific FODMAPs you and your individual gut, your individual bacteria, your individual intestinal muscles are sensitive to. And the goal, the process, essentially looks like what happens if we significantly decrease FODMAPs in your diet and we monitor your symptoms. What changes? Are you better, worse, or the same? If you get better, then what kind of FODMAPs can we reintroduce into your diet? What kind of FODMAPs can you tolerate? Because FODMAPs are good for you. Not all of them, but a lot of them are really, really good for you, which is why a low or no FODMAPs diet is not sustainable forever. There's a lot of bad things that can come of doing that for a long time. Because this elimination diet requires skill and knowledge to navigate correctly, and because high and low FODMAPs food lists are going to differ depending on which resource you're using, and because professional tools like hydrogen breath tests can be really helpful in further tailoring the diet to your specific individual needs, it is recommended in all of the literature that this type of diet, a low FODMAPs diet, is trialed under the supervision of a dietitian. All right, thank you all so much for watching. I know that I say this at the end of all of these videos, but it really is an honor, and I really am very excited to be making this content for you. So thank you again for watching and for commenting and for requesting. It really does mean a lot to me. I do still intend on making more videos in this series. I do still want to cover IBS and its relationship to anxiety, exercise, and sleep, as well as other treatment options for IBS like fecal transplants and alternative medicine and pharmaceuticals. Linzess, Trulance, and Viberzi have all been specifically requested. I'm also still curious about SIBO and how there may be some parallels and overlaps between SIBO and IBS. But if you have a request, if there is content that you'd like to see in this series that I haven't mentioned, please leave a comment down below and tell me what you're looking for. I try really hard to read and respond to all of my comments. If you found this video helpful, don't forget to like it and share it. Also, don't forget to check me out on Instagram, and finally, please subscribe to my channel for more videos, not only about pelvic things like today's video, but also about life things. Speaking of life things, I hope that you are staying safe and healthy during this uncertain time, and know that I am doing my best to upload regularly. I know some of you watching know that I am in the middle of healing my own pelvic injury of all things, and sometimes that does take my time and attention away from pelvic empowerment, but know that I am doing my best to heal and to continue to create content for you. So thank you again for watching. I hope that you have a wonderful rest of your day, and I will see you in the next video. Bye.